For question 9, it tells us we have a parallelogram EFGH with the vertices 1, 3 for E. F has a coordinate of 3, 5. G has a coordinate of 4, 2. And they want to know the coordinates of H. So clearly we're going to need graph paper for this. Got our answer choices. Here we go. 2, 0. Actually, not as hard as it could have appeared to be because it was on the graph. So, remember the whole definition of a parallelogram is having two pairs of parallel sides. Okay. Now, so that means, and it's obviously for the two pairs have to be opposite each other, otherwise the lines intersect, otherwise, and then you don't have a parallelogram, obviously. So these two sides have to be parallel. Now, think way back to when we did graphing of lines. Parallel lines have the same slope. Okay, so that means E and F have to have the same slope to be parallel to GH. Okay, so when I count the rise over run from E to F, it's 2 by 2. So that means, oh, I wrote this wrong, sorry. This is G, this is H, my bad. Actually, now that I'm thinking about it, that doesn't fit with how we're supposed to label parallelograms, and it has to be we have to go clockwise of G and H. So I was envisioning going up to right 2 to get H over here, but it also means we could go down 2 and to the right 2 and to the left 2 to make H over here. Okay. So, yep, down 2, yep, so this, okay, so there is that's our parallelogram, friends, right there. So, this point here is 6, 4. This point here is 2, 0. So, the key here, friends, is again making sure that they have the same slope. And when you count slope, okay, we counted up 2 and to the right 2. But I can also count down 2 and to the left 2, and for those points to be on the same line. All right, what do we have here? A scissor lift is used to lift heavy objects. The supports are joined to form parallelograms. Okay. In this model, the maximum height is reached when angle A is at 117 degrees. Okay, what is the measure of angle B when the lift is at its maximum height? All right, so again, parallelogram. So consecutive angles are supplementary. So it's just going to be 180 minus 117. Which, at this late hour, I do not trust my mental math. 63 degrees would be our answer. Pretty simple. All right, use the figure to match each angle. Okay. this is something that many of you struggled with on the last test, okay? Is just identifying angles. All right, so first what I notice is I see 4 90-degree angles. So that means what I'm looking at here is a rectangle. Okay, so first we have the measure of JKN. So follow the letters in order. So J, K, N. Okay, so that's this little angle right here. Okay. Now we cannot assume that the diagonals cut or bisect that 90 degrees in half into individual 45-degree angles. So, and as you can notice, 45 degrees isn't even an option. But what we can do, based on our 50 degrees here, is these are supplementary angles. So if this angle's 50, this angle's 130. Okay? And if you remember, with a rectangle, the diagonals are congruent. So that means these pieces are also congruent because they are the same length. And when we look at this, what we have here is an isosceles triangle with a vertex angle of 130 degrees. So that means the triangle J and K obviously has a 180 degree total. If I subtract the 130, that gives me 50 degrees remaining for these two congruent base angles, okay? So when I divide this by 2, angle JKN is 25 degrees. Okay? So it's going to be similar for the other. So measure J and K. So J and K. Well, as it turns out, that's this angle here, which we already determined is 130. And then our last angle, JLK. So JLK, that's this angle here. Okay. So again, we have an isosceles triangle with base angles congruent. The vertex angle at 50 degrees, that leaves a total of 130 degrees for these two smaller yellow angles. So when I divide 130 divided by 2, I get 65. Okay. A shelf in a warehouse is made of connecting steel beams. To safely hold its load, the shelf must be rectangular. Okay. Which measurement will ensure that ABC is a rectangle? Okay, so key property of rectangles is that their diagonals are congruent. So that means BD has to be congruent to AC. That is what's special about a rectangle and makes it different than a parallelogram, besides its 4 90-degree angles. So, there you go. It's BDAC. There you go. Those are those diagonals are equal, it is a rectangle.